All right, so we, like I said, are starting on absolute values. We are starting to look at absolute values as equations as opposed to just simplifying. So we simplified in that worksheet we just went over. Now what we're going to do is go back to reviewing solving, and then we're going to solve absolute value equations together. All right, so let's do that warm up. So if we are solving for a variable, what we want to do is go ahead and identify our variable and solve for it. So in that first example, you have two choices. You can either distribute to start or divide both sides by 5. A majority of us, I believe, would distribute. So you'd get 5x minus 30 equals 40. Add 30 to both sides. 5x equals 70. Divide both sides by 5. And we get x equals 70 divided by 5, which is 14. In number 2, we would have 5b equals 6b minus 16 because we distributed the 2. Subtract 6b from both sides. So your b's are on the left and your numbers on the right. And you get negative b equals negative 16. My variable can't be negative, so I divide both sides by negative 1. And I get b is equal to 16. In number 3, you want to first combine like terms on the same side. So 2y and 8y are on the same side. So you get 8y. 15 and 8 are on the same side. You ignore that negative 2y. 15 plus 8 is 23. I'm going to add 2y to both sides. And I get 10y equals 23. Dividing both sides by 10 gives y equal 2.3. You can also leave y as the fraction. These are equivalent or the same. Okay? The absolute value of a function is the distance a number is from 0 on the number line. It represents the distance a number is from 0 on the number line. The absolute value of x, x value is greater than or equal to 0, is always equal to x. And then basically what happens is the absolute value of x for x value is less than 0 is really like negative x, or looking at values to the left. An extraneous solution is a solution we find, but when we check, does not work. It's a solution we find, but when we check, it does not work. So it's a solution you find, but when you check, does not work. absolute value of a real number is considered its distance from 0 on the number line. An absolute value of a real number is its distance from 0 on the number line. So this is very similar to the worksheet you did this weekend, where you are simply looking at an absolute value of a number and determining its distance. Absolute values are like grouping signs in the sense that you must simplify the inside before you take the absolute value. So the distance 4 1/3 is from 0 is 4 1/3. The distance negative 9.2 is from 0 is 9.2. The change in 3 minus 8 is negative 5. Therefore, its distance is 5. The absolute value of 4 is 4. The minus is not part of the absolute value. It is the operation, so it stays. The absolute value of negative 5 is 5. So absolute value of 4 minus 5 is negative 1. Okay. And then number 23, or example, 23. For what value of x does absolute value of x equal negative x? Well, can I take an absolute value of a number and it equal a negative? There is only one number in the world that this holds true for. And that number is, what do you think? Anybody know? Sophia? Not 1. What do you think? 0. The absolute value of 0 is 0, and negative 0 is 0. So there is only one value of x that holds true. Okay, we can evaluate absolute value expressions by treating them like grouping simples. So over the weekend, all the numbers were plugged in for you. Now what we want to do is take the value we are given, like negative 7.5, and replace it for the variable in our problem. So we're going to replace all n's with negative 7.5. So we get 8.4 minus absolute value 2. Now instead of the variable n, we're going to plug in negative 7.5 plus 5. Remember, absolute value bars are kind of like parentheses. We're going to clean up everything inside the absolute value first. So the 8.4 minus tags along. And I'm going to get inside down to a single number. So 2 times negative 7.5 would give negative 15. Negative 15 plus 5 gives negative 10. So I simplify down to a single number. Then I take the absolute value. So absolute values are not like parentheses. That minus a minus does not become a positive. This becomes 8.4 minus the absolute value of negative 10, which is 10. So 8.4 minus 10 is negative 1.6. In number 2, all x's are going to be replaced with -2. So I get absolute value 4 times -2 plus 3, absolute value minus 3.5. So again, I either make my absolute values really thick or I make them tall so that I know it's an absolute value and not the number 1. So 4 times 2 is -8. -8 plus 3 is -5. So I have the absolute value of -5 minus 3.5. So I get 5 minus 3.5, which is 1.5. The notation with which we do these problems does not matter. Number 3 is the notation we're used to, where you are told, all right, x is equal to a number, and I'm going to replace that number in my problem. Number 4, this is called function notation. The same thing holds true. Everywhere you have that x, you're going to replace it with a -1. It's just that now my notation or setup changed a little. So let's start with number 3. Absolute value 9, -2, minus 3, absolute value plus 5. 9 times -2 is -18. Minus 3 more is -21. So you get the absolute value of -21 plus 5, which is really 21 plus 5, which is 26. In number 4, everything about the problem holds true, but now it looks like f of, and you replace that x with the -1 equals -3 absolute value. Replace the x with -1. All over 2. So you get -3. -1 plus 1 is 0. The absolute value of 0 is 0. 3 times 0 is 0. 0 divided by 2 is 0. Okay. Number 5. Same idea. We're going to plug in what we have. So x is -1/2. So that's like f of -1/2 equals 4. Absolute value, -1/2 minus 3. So you get 4. Absolute value, -3.5 or -3.5. So you get 4 times 3.5, which is 14. And then in 6, f of negative 2/3 equals 4 plus 2 absolute value, negative 2/3. Well, the absolute value of negative 2/3 is 2/3. So we get 2 times a positive 2/3. When you're multiplying a number times a fraction, you multiply the numerators. So that's like 4 plus 4/3. And again, if you did that on your calculator, it would give you as a decimal 5.3 repeating. So you would put the repeating bar over the 3, or you can hit math, enter, enter, and it would give you the fraction 16/3. These are the same, and either is fine. So again, I don't care if you give me the decimal, you just need to make sure you have the repeating, or if you give me the fraction. Okay, your homework is that next page, front and back in your handout. So it's a worksheet, and then it's the textbook problems. It's not, this might be a little off. So it's that worksheet on the front, and then the problems on the back. So it's only, yeah, it's only 14, that's what I said, that's a little off. It's just 14 to 21. Not 22. I got rid of the word problem. So it's the 14 to 21 on the back, and then the front.